Okay, prove that triangle ABD is congruent to triangle CDB. The key thing in this question that you might get stuck at the first hurdle is, what does congruent means? And it means exactly the same. The shape can be rotated, reflected, translated, but essentially it's still the same. Like this square is congruent to this square if they have sides 2 and 2. But if I made it into a 3 by 3 square, it would no longer be congruent. It would be a similar shape because I've actually multiplied by a scale factor of 1.5. Question is then, how do we prove that it's congruent? And actually, the first thing I should do is form the triangles. So let's do that. ABD is my triangle here that I'm outlining, and then CDB is this one here. Okay, and I need to show that they're congruent. Right, well, you do need to know the rules for congruency here, and they're very easy to forget, but here they are. If you can show that all three sides, and this is just for triangles, by the way, but this is the key. You don't need to really know rules for other shapes. I mean, I don't think there are very easy rules for other shapes at all. But for triangles, it comes down to this. If we can show, by the way, this means congruent. Sorry, this equal sign with a little kind of tilde above it. So that means congruent. So if you can show all three sides are the same length, then it must be congruent. Or if you can show that two sides are the same length and the angle in between them is the same on both shapes, then it's also congruent. This means side, angle, side, side, angle, side. If you can show that a side in between two angles is the same as a side between two angles, then again it's congruent, angle, side, angle. Or, and this is the one I tend to forget the most, if you can show that you've got an angle and then another angle followed by a side, then again, if you can show that's equivalent in the other shape, then they're congruent. The final one is if you have a right angle triangle, so R refers to the right angle, and then a hypotenuse in the side, then again that will be congruent. One to be aware of, well, angle, angle, angle does not imply congruence because it might just be an enlargement. Yeah, they will be similar in that case, but not in not congruent. But one to be aware of is that side-side angle is not sufficient for congruency because it could make two triangles. If you have 6, 11, 30, then you could actually, if you used a compass, you could draw an arc and make another 6, 11, 30 triangles. So just it's roughly, it's good to be aware of that one, but the main thing I'd say is learn these rules. Okay, I'm going to put them to one side for now because it's quite a lot to take in if you've forgotten this topic, for example. Let's just focus on trying to find some sides and angles that are equal, and we need, because it's a proof question, we need to give reasoning. So there's a really good one to start with, and that is DB. DB belongs to both triangles, so it's the same in both. DB is shared. I don't need to say anything more about that. Okay. What about some other ones? Well, if I look at, if on a parallelogram, we have two pairs of equal sides that are parallel. So I can write that down. I can say that DC equals AB. And then I might just give a reason. I'd looked at the mark scheme and it did accept parallelogram, but I would be a bit more technical and I'd say opposite sides of a parallelogram are equal. And actually, for me, the most natural thing to do then is do the other pair of sides. AD is going to equal BC. Same reason. So I've got three equal sides. Like, I've shown that the corresponding sides are equal, and I could just say by SSS, that's my defined rule of congruency, triangle ABD is congruent to triangle CDB. Do you know what? Sometimes I see it as this, although that means identical. I don't think we should use that. You can use the word congruent as well. I'm just writing it more concisely using the notation that I saw before. Is that the only way you can do it? Actually, the answer is no. You could also, or instead rather, you could have said that these two angles are the same. So, this is an alternative now. Angle CDB equals angle DBA. Yeah, this one is the first one, this is the second one. I need to give a reason for that, and they're alternate angles here. We've got this sort of backwards Z. And then you could maybe use side angle side, like one of the other ones anyway. You could even show that what other angles are equal, that this one here and this one here are equal. So there's actually lots of scope for this question. I think that side is the easiest, but you don't have to go with that. What we do need to do is clearly show when sides or angles are equal and why, and then give the conclusion with the correct rule of congruency. Basically, learn your rules of congruency, and this quite technical question is not as bad as it first looks, in my opinion.